Hi friends, welcome to Cracku's video series. In today's class, we'll be looking at CAT 2017 DILR sets. So in this particular video, I'll be solving the 5th and 6th DILR video from the first slot. We have already solved the first and second videos in one part and the third and fourth DILR sets in another part. So this is the third video in the series as such. So let's get started. Let's take a look at the DILR sets. The first DILR we'll be looking at is this. There are 21 employees working in a division, out of whom 10 are special skilled employees, SE, and the remaining are regular skilled employees, that is RE. During the next 5 months, the division has to complete 5 projects every month. Out of the 25 projects, 5 projects are challenging, while the remaining ones are standard. Each of the challenging projects has to be completed in a different month. Every month, 5 teams T1, T2, T3, T4 and T5 work on one project each. T1, T2, T3, T4 and T5 are allotted the challenging project in the first, second, third, fourth and fifth month respectively. The team assigned the challenging project has one more employee than the rest. So if you see, there are 21 employees and 5 teams. So there should be around 4 employees per team, and the team doing the challenging project has one more employee. So only that team will have 5 employees. The remaining 4 teams will have 4 employees essentially. In the first one, T1 has one more SE than T2, T2 has one more SE than T3, T3 has one more SE than T4, and T4 has one more SE than T5. Now if you see it in this way, suppose T5 has X SEs, then number of SEs with T4 is X plus 1, with T3 is X plus 2, with T2 is X plus 3, and with T1 is X plus 4. This should be equal to the total number of SEs that are available, that is 10. So we get 5x plus 10 is equal to 10. That means x is equal to 0. So T5 has 0 SEs, T4 has 1 SE, T3 has 2 SEs, T2 has 3 SEs and T4 has 4 SEs essentially. So that is what we can infer from this part. We also know that T1, T2, T3, T4 and T5 work on the challenging project in first month, second month, third month, fourth month and fifth month. The remaining time they work on the normal projects as such. And those who are working on challenging projects have 5 people, those working on normal projects have 4 people. So let's first start by representing this information. So we'll draw, this is some additional information about this, but first we'll start by drawing our basic, this saying that these are the teams and this is this. So we'll have teams as rows and we'll have the months as columns. So this is 1, 2, 3, 4 and 5. That is month 1, 2, 3, 4 and 5. And we'll have the teams as T1, T2, T3, T4 and T5. So this is T1, T2, T3, T4 and T5. So we know that T1 works on a challenging project in the first month, T2 in second month, and putting a star to indicate that, T3 in third month, T4 in fourth month and T5 in fifth month. So they'll have 5 people then. So I'll put 5, 5, 5 and 5. For all other cells, there will be 4 people. And we also know the distribution for the first month. We know how many of these were SE engineers and how many of them were skilled employees and how many were regular employees of these. So we know that T5 had no skilled employees. So this is 0 SE and 4 RE. T4 had 1 skilled employee. So this is 1 SE and 3 RE. And this had 2 SEs and 2 REs. Because the sum has to be 4. These guys would have again 3 SEs, sum is 4, so 1 RE, and these guys had 4 SEs and 1 RE. So this was the configuration at the for the first month. Now so I think we have used up all the information that is given here. So all of the information we have properly represented. Now let's take a look at the second part of the question. Between two successive months, the composition of the team changes as follows. The team allotted the challenging project gets 2 SE from the team which was allotted the challenging project in the previous month. So from the first month to second month, T1 has the challenging project in the first month and T2 has the challenging project in the second month. So from first month to second month, 2 SEs will go from team 1 to team 2. In return, one RE will be shifted from team 2 to team 1. So that is one change that will take place. After the above exchange, if T1 has any SE and T5 has any RE, then one SE is shifted from T1 to T5 and one RE is shifted from T5 to T1. Also, if T2 has any SE and T4 has any RE, then one SE is shifted from T2 to T4 and one RE is shifted from T4 to T2. Each standard project has a total of 100 credit points, while each challenging project has a 200 credit points. The credit points are equally shared between employees included in the team. So this is what we know till now. So based on these rules, we can then figure out the distribution of SE and RE for the successive months. So let's first write it down for the second month. So for the second month, we'll have to put 2 SE from T1 to T2. Also, we'll have to move one SE, if there is an SE, from T1 to T5 and one RE from T5 to T1 and one SE from T2 to T4 and one RE from T4 to T1. So let's do all of those changes. First, we'll do change A and then we'll have to check whether the conditions for team like point B are there or not. So first, we'll have to shift. So 2 SEs from T1 to T2. So these guys will have 5 SEs. And one RE that they have to send over here. So these guys will have 2 REs. And this 2 SEs were gone, so 2 SEs. But these guys also have to send 1 SE to T5 if they have an SE. And these guys have an RE and these guys have an SE. So this will be 1 SE essentially and 3 REs. And these guys will get that 1 SE and now they'll have 3 REs. Now, so the first switch is done. The second between T1 and T5 is also done. Now between T2 and T4 as such. So if between T2 and T4, if T2 has a SE, it has to give it to T4, and if T4 has an RE, it has to give it. Now T2 does have SE, so it will have to send one over here and it will have to accept an RE in return. So it will have 4 SEs now and 1 RE. And T4 will get an SE, so it will have 2 SEs and 2 REs. T3 has no change, so it will have 2 SE and 2 REs. So essentially at the end of the first month's exchange, in second month we have 1 SE 3 RE, 4 SE 1 RE, 2 SE 2 RE, 2 SE 2 RE and 1 SE 3 RE. So all changes are been done. Now the third month comes. Now people have to go from T2 to T3. So to go from T2 to T3, 2 SEs have to go here and 1 RE has to go there. So this will have, after the first change, this will have 2 SEs and 2 REs. Then these guys will have 4 SEs and 1 RE. Now this is the first point. Now T1 has to send to T5. So T1's SE will go away and it will now have 0 SEs and it will get 1 RE in return. So it will have 4 REs. These guys will get the SE. So these guys will be 2 SE and 2 RE. There will be another switch between T2 and T4. So T2 will lose another SE and get an RE. So it will be 1, 3. And these guys will get an SE. So it will be 3 SE and 1 RE. So we have at the end of the for the third month, we have 0 SE 4 RE. We have 1 SE 3 RE. We have 4 SE 1 RE, 3 SE 1 RE, 2 SE 2 RE. So this is the distribution for the third month. Now let's come to the fourth month. In fourth month, 5 from 2 SEs have to come from team 3 to team 4. So that would be, these have 5 guys already, 3 guys already. So it will be 5 SE and 0 RE. Because that RE has to go to this team essentially. So this guys will be 2 SE and 2 RE. Now let's check for switch between T2 and T4. T2 and T4, the switch is not possible because these guys don't have any these two switch as such. So after because they don't have any REs, they can't send any RE, so they will not be able to accept this SE also. So this switch will not occur. So that is, they will be as it is. Now between T1 and T5, between T1 and T5, these guys also don't have anybody to give, so no switch will occur. So this will be 2 SE, 2 RE. Now, so at the end of the 4th month, we have 0 SE, 4 RE, 1 SE, 3 RE, 2 SE, 2 RE, 5 SE, 0 RE, and 2 SE, 2 RE. Now we come to the 5th month. Now 2 guys will come over here, so it will be 4 SE and 1 RE. So these guys have lost 2 SE, so this will be 3 SE and 1 RE. Now let's check whether the other switches are possible. Between T1 and T5, these guys have no SE to give, so they can't do any switches. So this will be 0 SE, 4 RE as is, and T1 and T5 are set essentially. Now between these guys, T3 is essentially not affected by any of these changes, so this will be 2 SE and 2 RE. Now between T2 and T4, T4 has 1 RE, T2 has 1 SE, so the switch is possible. So the switch will happen, and these guys will have 4 REs, and these guys will have 4 SEs and 0 REs, and this is 0 SE. So at the end of for the 5th month, the distribution will be 0 SE, 4 RE, 0 SE, 4 RE, 2 SE, 2 RE, 4 SE, 0 RE, 4 SE, 1 RE. So this is the entire distribution over the 5 months. So now that we have made this table, we can now go on to answer the questions. The number of times in which the composition of team 2 and the number of times the composition of in which the composition of team 4 remain unchanged in the successive months are. So let's go and check the table. T2 and T4, how many times is the composition of T2 and T4 unchanged over successive months? So T2, here it changes, here it changes, here it does not change. So over 3 and 5, T2 remains same between 3 to 4. And over here it again changes. So one month without any change for T2. For T4, it is changed here, change over here, change over here, change over here, and change over here. So there is 0 months for T4. So essentially the number of changes is 1, 0. For T2 there is 1 month without any change, and for T4 there is 0 months without any change. So the answer is 1, 0. Let's take a look at the second question. The number of SE in T1 and T5 for the projects in the 3rd month are respectively. So let's see, in the 3rd month T1 has 0 and T5 has 2. So the answer is 0, 2. So the answer is T1 has 0, T5 has 2 in the 3rd month. Which of the following cannot be the total credit points earned by any employee from the projects? So let's take a look at the points thing again. So the points thing is, each standard project has a total of 100 credit points, and each standard project has 4 people. So if you're working on the standard project, you will get 25 points, that is 100 by 4. And each challenging project has 200 points. So if you work on a challenging project, you will get 200 by, and there are 5 people in a challenging project, so you'll get 40 points. So this is the general formula for getting the number of points. Now suppose an employee works for X challenging projects. So since he has works on 5 projects in all, so he'll have to work for 5 minus X normal projects. So for a person, the number of points essentially will be 40x for the challenging plus 25 times 5 minus x. So this is essentially 40x plus 125 minus 25x. So that is 125 plus 15x. So now suppose if x is equal to 5, that he works on all the challenging projects. If x is equal to 5, this becomes 125 plus 75, that is 200 points. When x is equal to 4, this is 125 plus 60, that is 185. When x is equal to 3, this is 125 plus 45, that is 170. When x is equal to 2, it is 125 plus 30, that is 155. and when x is equal to 1, this is 125 plus 15, that is 140, and when x is equal to 0, this is 125 points. So this is the distribution overall. But if we see from the options, 140 is possible, 170 is possible, 200 is possible, but 150 is not possible. Therefore, the right answer is option B. Now let's go to the last question of the set. One of the employees named Anik scored 185 points. Which of the following cannot be true? So then the options are given. He worked in teams T1, T2, T3, T4 and some other combination of teams. Now let's see when can 185 points happen. So as we saw from here, 185 points happens when x is equal to 4. And x is equal to 4 means that he worked on 4 challenging projects. So essentially he has to work on 4 challenging projects, and if he works on 4 challenging projects and 1 normal project, he must go from like 1 challenging project to another 4 times. So let's see how somebody can transfer like that. So the first option is Anik worked only in T1, T2, T3 and T4. So let's take a look at the distribution again. So suppose this is T1, T2, T3 and T4. So if Anik worked in this team in the first month, then transferred to this team when like it gets 2 SE engineers at the start of the month, right? So our skilled employees at the start of this, right? So 2 skilled employees go from T1 to T2. Anik could be one of those guys. Again, when he in the third month, 2 skilled employees go from T2 to T3. Anik could be one of those guys. Again in fourth month, 2 go from T3 to T4. So Anik could be one of those guys. And the non-normal project can be when he is still in the normal, he just remains in T4. He is not transferred out of T4 in this case, where 4 skilled employees remain. So he is one of those skilled employees and he just remains in team 4 for the 5th month. So in this case, he worked in 1, 2, 3, 4 challenging projects and 1 normal project. So he can then have 185 points. Let's take, so this is definitely possible. Now let's take a look at Anik worked only in teams T1, T2, T4 and T5. So let's take a look at those teams again. So T1, T2, T4 and T5. Now how can somebody go from T2 to T4? They can go from T2 to T4 in the swap that happens, where T2 has to give off 1 skilled engineer and T4 has to give back 1 1 skilled employee in T4 has to give a regular employee. So suppose Anik worked in T1 in first month, then T2 in second month. So he has worked on 2 challenging projects. So that is, I'll show that. So if he is working here, then here, now instead of going to T3 when the skilled employees are sent, he goes, so here there were 4 skilled employees. So 2 were sent to T3 and 1 was sent to T4. So the one who was sent to T4 could have been Anik. So he goes here, and this is a regular project. Then he is part of the team still. So he is on the challenging project in T4, and then he goes to T5. So he is now again part of the challenging project. So he has been part of 4 challenging projects and 1 normal project. So he can earn 185 points that way. So option B is definitely possible. Now let's see the third option. The third option is T2, T3, T4 and T5. So again, let's go back to this. Now let's say suppose somebody was part of T2 to start with. Then they are not moved when the second month comes. They are part of the challenging project. Then they move to the T3 in the third month. Then T4 in the 4th month and T5 in the 5th month. So they'll be part of 4 challenging projects and 1 normal project. So they'll earn 185 points. So essentially this option is clearly possible. So let's go and mark that off also. So sorry, all of these are eliminated and this option is also eliminated. Now let's see the 4th option. Anik worked only in teams T1, T3, T4 and T5. Now let's consider how. The thing here is, this says that somebody went from T1 to T3, but it is impossible to go from T1 to T3. If you have to go from T1 to T3, one way to go is if you go from T1 to T2 and then to T3. There is no other way. From T1 you can go to T2 or you can go to T5. So from T1, when it passes on the challenging project to T2, then you can go to T2, or from T1 you can go to T5 whenever at the end of every month it has to send one skilled employee over. So from T1 to T5 is possible, but it is impossible to go from T1 to T3. So as a result, you cannot have worked gone from T3 to T1 to T3, and you have to work on 4 challenging projects. So essentially it can't be that you worked on T3, T4, T5 and then went to T1 as a regular employee, because if you went to T1 as a regular employee, you would not work on 4 challenging projects. So option D is impossible. Therefore, the option D cannot be true. So as you have seen, this question became very easy once you made that table. The table will take you like some 5 to 6 minutes if you do it quickly and are focused on it. And once you have done that, attempting the questions would not have taken much time. So this was a pretty simple DILR set and you should have attempted it. It would have been solved in like around 10 minutes or so, and it would have been a good LR set as such to attempt. So let's take a look at the next LR set. In a square layout of site 5 meter into 5 meter, 25 equal size platforms, square platforms of different heights are built. The heights in meters of individual platforms are as shown in the table below. Individuals all of same height are seated on these platforms. We say an individual A can reach individual B if all the 3 following conditions are met. Firstly, A and B are in the same row or column. So only row and column is considered, not diagonals. 2, A is at a lower height than B. And third is, if there is or are any individuals between A and B, such individuals must be at a height lower than that of A. So it's pretty simple. So for example, I think they have given in detail. Thus in the table given above, consider the individual seated at height 8 on third row and second column. So they are talking about this guy. He can be reached by the individual on his left at height 7 because 7 is less than 8, and by the 2 individuals on his right at 4 and 6. So 4 can reach 8 because 4 is lower than 6. 6 can reach 8 because 6 is lower than 8, and in between 4 is there and 4 is lesser than 6. So 6 can reach 8. And 5 can reach 8 because 5 is less than 8. 1 can't reach 8 because though 1 is less than 8, 5 is taller than 1. So 1 can't reach 8. 9 is greater than 8, so 9 can't reach 8. So we can understand how these rules are working. So the rows are numbered from top to bottom. So this is 1, 2, 3, 4, 5, and columns are numbered from left to right. So this is 1, 2, 3, 4, 5. So if you can see this is that how many people can be reached. So all the questions that are there in this particular set is how many people, this cell can be reached by how many people. So let's first begin by answering that, drawing the same table, 5 into 5 table, and figuring out for each cell how many people can reach that cell. So we have this table, we'll draw another corresponding 5 into 5 table. So we have 1, 2, 3, 4, 5, and we have 5 rows. Okay, so the way I go about this is that we know that to reach somebody, the other person has to be at a lesser distance than that person. So we know there is no person below 1. So 1 essentially cannot be, the guys at height 1 cannot be reached by anybody because there is nobody at a height lesser than 1. So we can directly start off by putting zeros over here. So for the 3 ones, we can directly put zeros. So the guys at 2s can only be reached by the guys at 1s. So this 2 can be reached by this one. So it has 1. Then we have another 2. It does not have any 1s in its vicinity. So it cannot be reached by anybody. Then we have a 2 over here. It has 1 in its vicinity. So the answer here, the number here is 1. So we have filled all the 2s as such. Now let's go for the 3s. There's 1 3 here. There is 4 and 8 in its vicinity, so nobody can reach it, so this is a 0. Then we have a 3 over here. There are 2 2s in its vicinity, so he can be reached by both of these 2s. So this is a 2. Now let's go, the third 2 is 3 is here. There's only one over here, so this 3 can be reached by one person. And there's a last 3 over here. This 3 has 1 in its vicinity, so it can be reached by one person. Now let's go to 4s. So we have a 4 here. So this 4 can be reached by this guy, by this 3 and by this 2. This one, though lesser than 4, can't reach because 2 is taller than 1. So 4 can be reached by 3 people. Now let's see the next 4 is over here. So this 4 can be reached by 3 and the remaining numbers are greater than 4. So for this 4, the answer is 1. Now let's see, so we have placed all 4s. Now let's go on to 5. So the first 5 is here. It can be reached by 1, so 1, and by 3. It can't be reached by 2 because 3 is taller. So this 5 can be reached by 2 people. Let's see this 5. This 5 can be reached by only the 2 at the bottom. So the value is 1 for this. Now let's go on to the 5 over here. So this 5 can be reached by this 4, by this 1 and by this 2 also, because 2 is less than 5 and in between there's 1 which is shorter than 2. So it can be reached by 3 people. Now we have placed all 5s. So let's go on to 6. So the first 6 is here. This 6 can be reached by 1 and by 2 and by 4. So it can be reached by 3 people. So let's see the next 6. The 6 over here. So this 6 can be reached by 2 and 4. So 2 people till now. By 5 on the right. So 3 people till now. By 1 on the bottom. So 4 people till now. By 3 on the bottom. So 5 people till now. And by 4 on the right. So 6 people in all can reach this 6. Now let's go on. So this is the last 6. So this 7 can't reach it. 5 can reach it. So 1 person. 4 can't reach it. 3 can reach it. So 2 people. So this 6 can be reached by only 2 people. So we have placed all the 6 as such. Now let's move on to 7s. So this first 7 is over here. 9 can't reach it. 8 can't reach it. 3 can reach it. The 1 can't reach it. So this 7 can be reached by 1 person. Now the other 7 is over here. This can be reached by 1. 9 can't reach it. This can be reached by 6. 3 can't reach it. So 2 people can reach this 7. So we have placed all the 7s also. Let's go on to 8s. So 8 can be reached by this 3. 2 on the side. So this is 1. 3 is 1. This 2 is 2. This 3 also can reach. So that's 3. This 5 also can reach, so that's 4. This 5 can reach, so that's 5. So 5 people can reach this 8. So we'll write down 5. Now let's go to this 8. So 5 can reach it, so that's 1. This 1 can't reach it. This 4 can reach it, so that's 2. This 6 can reach it, so that's 3. This 9 can't reach it, but this 7 can reach it, so this is 4. So 4 people can reach this 8. So we have placed all the 8s also. So let's go to the 9s. So 9s, this 6 can reach it, so 1. This 5 can reach it, so 2. This 3 can't reach it. This 7 can reach it, so 3. This 3 can't reach it. So that's 3 people. Let's go to this 9. So this 9, this 8 can reach it, so 1. This 5 can't reach it. This 5 can reach it, so 2. This 1 can't reach it. This 7 can reach, so 3. And this 3 can reach, so 4. So 4 people can reach that 9. Now let's see the 9 in this corner. This 2 can reach it, so 1. This 5 can reach it, so 2. This 8 can reach it, so 3. This 3 can reach it, so 4. This 6 can reach it, so 5. This 7 can reach it, so 6. This 1 can't reach. So 6 people can reach this 9. So we have made a table for every how many people can reach a particular cell. So now let's go on to the questions. So this table is given as shown. So how many individuals in this layout can be reached by just one individual? So let's just count the number of ones. So the number of ones is 1, 2, 3, 4, 5, 6 and 7. So 7 individuals can be reached by just one individual. So the answer is 7. So let's go on to the second question. Which of the following is true for any individual at a platform of height 1 meters in this layout? They can be reached by all the individuals in their own row and column. They can be reached by at least 4 individuals. They can be reached by at least 1 individual. They cannot be reached by anyone. As we know that anybody who is at one height logically cannot be reached by anyone because there is nobody at a height lower than him. So the answer is option D. Let's take a look at the third question. We can find 2 individuals who cannot be reached by anyone in which of these following? So the last row, there is only 1 individual. So this is not the right answer. In the fourth row, there is only 1 individual. So again, this is not the right answer. In the fourth column, there are 2 individuals. So this is the right answer. In the middle column, there is no one. So that's not the wrong answer. So the right answer is option C. Which of the following statements is true about this layout? Each row has an individual who can be reached by 5 or more individuals. That's not true. The first row does not have that. So this is clearly wrong. Each row has an individual who cannot be reached by anyone. So if we see, this is true for the first row. This is true for the second row. This is not true for the third row. So clearly this is also wrong. Each row has at least 2 individuals who can be reached by an equal number of individuals. So what does it mean by equal number of individuals? That means there will be 2 repeated numbers. So let's take a look. So this is true for the first row, 3 and 3. Then 2 and 2. So this will be true for the second row. Then 1 and 1. So this is true for the third row. Then 1 and 1. So again true for the fourth row. And 2 and 2. So true for the fifth row also. So this is true. Each row has at least 2 individuals who can be reached by an equal number of individuals. So this is true. Let's check option 4 just for the sake of it. All individuals at height 9 meters can be reached by at least 5 individuals. This is definitely not true. Just take a look at this one. This guy is at height 9 but can be reached by only 3 people. So this is also wrong. So as you can see, the answer to this question is option C. So as you saw, once you drew that 5 into 5 grid, you could answer all the questions that were given. Now the reason why I drew a grid in that particular way was because I knew that the questions were asking, in each question you were asked, how many people can this person be reached by? Once you have figured out what is needed, you have to then draw a table that would help you answer that particular type of questions. So this is, as you saw, once you drew the right table, the answering the questions was pretty easy. So this is how you solve LR sets which require you to do basic amount of data manipulation. That is essentially changing one table into another table, which is useful for you to answer the questions. So we have solved 5th and 6th DILR set in this video. Please see our next video where we'll be solving the 7th and 8th DILR set. Also please check subscribe to our video series to keep getting more videos like this. We'll be solving a lot more questions from CAT 2017 and giving a lot more tips and preparation and material for CAT 2018 as such. Also please do check out our description box. We have given links for a lot of free stuff there. The link to our free mock and all other videos as such that will be helpful for people who are preparing for CAT 2018 as such. So please subscribe and check out the description box. Thank you.